We'll walk through the entire process of modeling and deploying a structural model using the plugin from the 3D model to drawings and quantities. We'll start with the column drawing module. Based on the grid system already in the model, just select the grid, open the column module, and set the section size and column height. The system will automatically generate columns in the selected positions quickly and accurately, based on the input parameters. Next is the beam drawing module. Users just need to select the beam size and snap the start and end points along the grid or at desired locations. Beams will be automatically created with the correct section, direction, and connection points to the structural system. The plugin supports a fast and accurate snapping mechanism, which is highly optimized for working with structural grids. This makes the modeling process much more convenient, reducing manual tasks and minimizing errors. Additionally, we can copy components to create new objects. At the same time, you can change the cross-section for multiple objects in a single action. Batch editing saves a lot of time during model deployment. Similar to columns, the plugin also supports batch copying and editing of heights, lengths, or other geometric parameters through the Quick Edit module. This is especially effective when you need to update structural options during the design process. Next is the foundation drawing module. Users can quickly deploy foundation types like isolated footings and other forms that fit the structural plan being used. After that is the slab drawing module from the beam and column system. Just select the relevant beam and column objects, and the system will automatically detect the boundary and create the slab quickly. Next is the automatic component naming feature. The plugin supports batch naming of components, ensuring compliance with naming conventions while matching the corresponding size and component type. This feature makes model management clearer and more consistent. For slab elevations, the plugin has a dedicated module to manage information such as slab name, thickness, and elevation. When you need to change the model elevation, for example, lowering the entire model by 50 mm, you just need to update the value and the system will automatically adjust it. Then, with just a single update command, all elevation information for the related components will be synchronized instantly. Next is the section for creating views and scenes for drawing presentation. For example, with the second floor structural slab layout, we just need to select the objects to display, switch to top view, and then create a separate scene for this layout. When you need to display beam or slab names, just select the object and use the text tool module to turn on labels on the layout. Component tags will be generated automatically, making annotation quick and clear. Similarly, we can create a scene for the first floor beam and slab layout. Just select the right objects, turn on Show Selection Only, create the scene, add tags, and adjust the tag positions to make the drawing easier to read. Once done, just update the scene, and all settings will be saved. For the foundation structural layout, the process is exactly the same. We select the objects to display, name the scene, and add label tags to the foundations. Tags will be created automatically, and users can continue to adjust the position and display size according to the drawing scale to achieve the clearest layout. Next is the quantity takeoff and estimation section. We open the estimation module, assign estimation codes to each component group, and then select the objects in the model. The system will automatically calculate quantities and apply unit prices from the pre-configured data. The schedule will be categorized into different groups, with cost summaries, support for searching specific components, and the option to export to Excel for takeoff, verification, and estimation work. Next is the beam reinforcement deployment. The geometric information of the beam is stored in the model. Therefore, we can reload the data, identify span lengths, and save parameters for future editing and updates. Users only need to snap 2 points. The system will automatically arrange the longitudinal reinforcement in the beam according to the preset parameters. When needed, we can switch to 3D rebar display mode for visual inspection in the model. Notably, from this 3D rebar model, the plugin allows you to quickly export 2D drawings in just a few steps. Just select the object, choose the section, creation tool, and the system will automatically generate 2D section drawings for presentation. This allows users to switch to layout to finalize the documentation with almost no manual redrawing. Thank you for watching. That concludes the introduction to the plugin.